This is project 5 video number 3, the one in which we do the documentation and finishing touches. I've actually gone ahead and put my documentation in here, so just review that. I got right after the function statement, I've got a comment in which I'm saying right here that you have to state what the function does. In other words, you got to say this function calculates the x component of the electric field at point xp, yp due to a set of 100 charged particles lined up along the x-axis from 1 centimeter to 100 centimeters at 1 centimeter spacing, where the charge of each particle depends on its position according to this function, which you can include in your comments. That's probably about what it is. So say something like that, but in your own words. Then say by and write your name. Make sure you get your name in it. Don't forget your name. And then a list of the input variables. We got the two arguments of the function are the input variables. So write down xp, say what it is, the abscissa of the position of the empty point in space at which we're calculating the x component of the electric field, yp, say what it is. Then you got one output variable, the return variable here that matters, e sub x total is what I'm going to call that, and say what it is, the x component of the total electric field at the empty point in space, point P where you calculate the x component of the electric field. I felt, as far as clarification of the code, I chose symbols like that we use in physics and discussing these kinds of things, and use standard MATLAB statements. So it's in my opinion, pretty self-explanatory. In other words, I made the code self-documenting by picking reasonable variable names. If if I pick instead of using XP up here, well, maybe that's not good. Instead of using R right here, I use my initials. Then I should explain what that variable is, but because I used R, it's going to be pretty clear to anybody that knows a little bit of physics and a little bit of MATLAB coding that R is the distance from the point in question to the empty point in space, and in this case it's an array of such distances. So I made it self-documenting so I wouldn't have to include a lot of documentation. When you're writing code, you should do that. And then for the attribution, tell the story of how you wrote the code. So your story might be like I did the pencil and paper part on my own. I didn't even bother to check it against yours. Then I wrote the code on my own. It didn't work. I looked at your code and I couldn't make out what went wrong. Then I looked at your pencil and paper and I realized I had made a mistake in the pencil and paper part. I fixed that. Then I fixed the same mistake in my code without looking at your code again, and it worked just fine. And I checked to make sure I was getting the same answer that you did for the case that you did. So and it was. And then I wrote the documentation up on my own, and I checked your video 3 and realized I'd forgotten to put my name in it, so I got my name in it, and that was it. I had the input and output variables, the description of the function, and the attribution. So something like that. In other words, let me know how you came to have this code, especially where you used my help. It would be cool if you said, well, I was doing it on my own. I looked up, I searched the internet for MATLAB sum to find out how you add up all the elements of a vector. That would be excellent. But that's the idea on that. Let's go ahead and go through our checklist. You might say that in your documentation. Went through the checklist on my own, and then when I checked the documentation part, I had it all right. When I looked at your video, I had everything in there. So pencil and paper's got to have algebraic solution, including diagrams. Oh, there are steps. It's got to have that, an outline of the code. There's my algebraic solution. There's my diagram. I think I'm good. For each function, outline of the steps the program will execute. I showed that. So good for the pencil and paper. Reasonable attempt at writing the program. I should get that. And it does consist of a .m file. for it to be a reasonable attempt, you got to make a .m file. And I got that. So one for a program that works properly, do what it's supposed to do, and not print anything extra to the window. So here's where I run my code with a semicolon at the end. Well, first off, if I do the semicolon, it gives me the return variable. I mean, without the semicolon, it gives me the return variable. With the semicolon, I get nothing back. It's still calculating it, it's just not showing it. In fact, if I if I say EFX equals, and then my function with its arguments, then I have assigned the output of my function to the variable EFX, and so if I just type EFX to see what's in there, there it is, the same answer that I got when I ran the function without the semicolon. So yeah, it's not printing out anything extra to the screen. I'm good there. Boy, for documentation and finishing touches, that's what I'm working on. Name in every .m file, got that documented. Comment, saying, well, I didn't really say what it does, but I told you to say what it does, so I got that comment in there. Comment for the input variables, I put that one in there. Again, I didn't do it completely. You got to do it. Make sure you don't hand in a piece of paper that's got or .m file that's got "say what it is" written there beside the variable. You have to say what it is for each input variable, and I got the output variable same way. Actually, say what it is. You have to say what it is. And what else we got? Return variable, so that's the output variable. I got that. Not self-explanatory. I talked about that briefly. I made it so it was self-explanatory. The only comment I added was the Coulomb constant. That's probably even overkill. Again, if you know a little physics, you know that what I'm doing there. So got that covered. Doesn't make any graphs, so I can skip that. Provide attribution. Yeah, I don't think your attribution statement is going to be identical to mine, because what did I say? Tell the story of how you wrote the code. You better not write that. So actually, tell me the story. We discussed that. So I think I got it covered. I've already saved it and run it. I guess I can just make sure. So I think I'll run it that way once, nothing extra printed, and then run it that way. It does give an answer. And while I was working on it, I checked whether or not that answer seemed reasonable. Some checks. I don't think I have checked that as thoroughly as I have others, but I'm confident that it's good. So let's call that a wrap on project number 5, video number 3.